Alright, this is another example of a shortest path problem using Dijkstra's algorithm. Here it's more clear cut. They want us to go from the start to the finish and work out what the shortest path is through this graph. So again, we could do it via trial and error, which is a definite possibility with a graph this small, but I'd be willing to bet that VCAR will work out a way to assess whether you understand how Dijkstra's algorithm would do it. So we need to be really comfortable using this particular algorithm. Alright, so remember what we do is we use a table to actually process the graph, and the first vertex that we're going to use is S, the start, and then what we do is we list all the other vertices across the top here. So we've got A, we've got B, C, D, E, and F. Alright, then you just rule a line down and across. Okay, so from S we've got three potential vertices that we can go to in the shortest path. We can either go to A, B, or C. A will be 7, B will be 5, and C will be 8. So let's write these down in this table. So S to A is 7 from the start. S to B is 5 from the start vertice, and S to C is 8, also from the start vertice. We can't get to either D, E, or F, so let's cross them out just at this stage. Alright, box up smallest amount. That becomes the focus of our attention, is B. So we write 5S, and now we check what we can do from B. From B we can get to D, and from B we can get to E. We can also get back to S as well, but we don't worry about that because S is not on that list there. So we look at the vertices that we can go forward to, I suppose. Alright, so from B we can get to D. That's going to be 5 plus 4, which is 9. So we write down a 9 from B. And we can even write a little 9 there. We can also go 5 plus 7, which is 12, to E from B. Alright, now we know that 12 is not going to be the final figure for E because we can see really quickly that S, C, E will be 10 and 10 will be 12. But again, what Dijkstra does is just brute forces all the possible methods of doing it and getting to F. So this is just one it's going to try out and see whether it can work or not. Alright, because we can't get to A and C, we simply rewrite those values, 8 from the start and 7 from the start. Alright, we now look through, and that's across because we can't get to F directly. We look through all of the remaining edges and see whether, or which one is the smallest one, and it's this one here, so box it. A becomes center of attention, 7 from the start, 5 from the start, and let's see what we can do from A. From A there's only one place we can get to, and that's D. 7 plus 3 is 10. 10 won't beat the 9 that's already there, so I know that 9 to D will stay the same. And what I do is I basically just check again. From A I can't get anywhere else, so the 8 from the start stays, and the 12 from B stays for C and E. I still can't get to F, so that remains crossed. Alright, we've got 8, 9, and 12. Box up 8, the smallest number. That comes from vertex C, so I write down C as the center of attention. 7 from the start, 5 from the start, 8 from the start. Alright, now we're at C. C only goes one place, and that's to E. 8 plus 2 is 10. 10 beats 12. So I replace the E, 10 from C. Alright, I can't get to D, so that just stays at 9B, and I still can't get to F, so that stays crossed. Alright, 9 is the smallest number, box it, that's D. rewrite boxed edges, 5 from the start, 8 from the start, 9 from B. Alright, now we're at D, which is there. D, I can get two places. I can either get to E or I can get to F. Now, D, so 9 plus 1 is 10. Okay, so from D to E is 10. That's the same as that. So I'm just going to leave it as is. Now I can also get to F. 9 plus 6 is 15. Alright, so 9 plus 6 is 15, so I write down 15 from D. Alright, I look through my list now down here and I've got a 10 and a 15. Okay, so let's box up E as that. E becomes center of attention. Boxed values get written down. 5 from S, 10 from S, 9 from B, 10 from C. And we're at E. E is, we're on 10. 10 plus 8 is 18. 18 doesn't beat 15. So 15 stays there. And we box it because it's the only one left over. So obviously it's the smallest one. Alright, so what do I know? I know that my shortest path will be 15. Okay, that's that value there. But I can also tell how we've arrived at that value, because to get to F we came from here, D. Alright, that line there. Alright, so let's rewrite them in reverse order. Now to get to D, I look down this column here and I know that I came from B. Okay, so I came along here. And how did I get to B? Let's have a look. I came from the start. I came from there. So let's just check it out and make sure it all adds up. 5 plus 4 is 9. 9 plus 6 is 15. So that's our shortest path.